What is the loudest sound you have ever heard? People living near or working at blasting sites will testify to how the loud sound can terrify humans and pets, especially when the sound is unexpected. However, much more powerful explosions are taking place every second in the universe. Some of these cosmic explosions are so far away that we are seeing them billions of years after they occurred. However, in this video, we bring you the shocking largest explosion in the universe that just occurred. Explosions may be scary and destructive, but they are oftentimes useful. For example, road builders use it to create paths through solid rock, and miners may use it to get to important minerals buried in the ground. However, everything that happens today is due to an explosion known as the Big Bang. Technically, it was an expansion, but it was how everything got here. The Big Bang is a popular expression, especially if you've watched the Big Bang Theory show, which understandably took some liberty with science to make the show as glamorous as possible. However, how did the Big Bang work out? It's easy to imagine, actually. We know that the universe is always expanding in all directions. This can be observed from galaxies that are moving apart at a speed that is increasing. Now, reverse the expansion process, and you begin to compress the universe. At a point, the universe becomes so small that everything is squeezed tightly into a single, infinitely small point that is super hot and immensely dense. About 13.7 billion years ago, the expansion of the universe started. It has not stopped since. In those billions of years, countless cosmic explosions have taken place. Some of them have been more powerful than others, but what causes these powerful cosmic explosions? Well, the most powerful kind of cosmic explosions known to science are called gamma-ray bursts, also known as death from space, and we will show you how they happen in a bit. These galactic events are so fierce that their extraordinary intensity is only surpassed by the Big Bang itself. In a matter of seconds, the process can emit as much energy as a star the size of our Sun would in its entire lifetime. These intense flashes occur all the time, but thankfully, they usually take place in galaxies billions of light years away from Earth, sparing us from intense jets of particles thrust at the speed of light from collapsing stars. However, because we don't get any forewarning of these bursts, it is not easy for scientists to observe them. Complicating things further, these massive explosions usually only last a matter of seconds, making it nearly impossible to act fast enough even when alerted. Gamma-ray bursts occur when a dying star collapses to become a black hole. An extraordinarily massive dying star can collapse its core into a black hole without triggering a supernova. With the sudden removal of the stellar core, the upper layers of the star come crashing down to fill in the cavity. If the star is spinning rapidly, the infalling material is whipped up to a swirling frenzy, and a disk forms deep inside the star. In the ensuing vortex, superheated plasma is ensnared by highly twisted magnetic fields. Like an electromagnetic cannon, jets of gas blast through the star's poles and erupt into space. The tunnel through the star forces the plasma streams into narrow cones, tightly focusing the energy of the collapse. Gamma-ray bursts are unique in astronomy. The most distant object seen by astronomers is a burst whose light has been traveling for nearly the age of the universe. The stellar behemoth that produced it exploded shortly after the period of the first stars. Besides, another gamma-ray burst is the most energetic event known. It was 2.5 million times brighter than the brightest supernova. And supernovae, for the record, typically outshine entire galaxies. For 30 seconds in 2008, it was the most distant object visible to the naked eye at about 7.5 billion light-years. Now, any gamma-ray burst you see happened a long time ago, but the light is only reaching us now because of the vast distance. This is why they are sometimes described as messages from the beginning of time, when the most massive stars in existence violently collapsed. What is the farthest explosion from the Earth ever recorded? That title goes to a gamma-ray burst, GRB, that took place about 13 billion light-years away, or at a time when the universe was just 630 million years old. The burst most likely came from the explosion of a massive star, meaning we are witnessing the death throes of a star and most likely the birth of another massive black hole. GRBs are what happens to stars when they run out of fuel and collapse on themselves. Just how far away is this explosion? 1 light year is about 6 trillion miles or 10 trillion kilometers, which means this explosion took place 78 trillion miles or 130 trillion kilometers away from us. That is safe enough, right? NASA's Swift satellite detected the 10-second-long gamma-ray burst produced by the ancient long-distance explosion in the early morning in a day in 2009. The satellite quickly swung about to point its ultraviolet, optical, and X-ray telescopes. The satellite found a fading X-ray afterglow but no visible light. This was a key identifier that the object exploding was a distant one. This is because the ongoing expansion of the universe eventually converts all visible light into longer infrared wavelengths. Astronomers located in Europe and the US immediately swung into action to follow up on the stunning discovery. They discovered that the infrared light of the afterglow had the highest redshift ever measured, meaning that the wavelengths had been very stretched out during their long journey to reach us. Before this, the Swift satellite had made record-breaking discoveries, including a gamma-ray burst that it detected in 2008. However, the burst came from an exploding star that was just 12.8 billion light-years away. Let's now go to the third largest cosmic explosion in the universe that we know of. That will take us back to 2005, when astronomers found the most powerful eruption seen in the universe using NASA's Chandra X-ray Observatory. It was a supermassive black hole behind this eruption that was growing at a remarkable rate. The colossal eruption was seen in a Chandra image of the hot X-ray emitting gas of a galaxy cluster called MS0735 6+7421. Two vast cavities were extending away from the supermassive black hole in the cluster's central galaxy. The eruption, which has lasted for 100 million years and is still going, has generated the energy equivalent to hundreds of millions of gamma-ray bursts. Radio emission within the cavities shows that jets from the black hole erupted to create the cavities. Gas is being pushed away from the black hole at supersonic speeds over a distance of about 1 million light-years. The mass of the displaced gas equals about 1 trillion suns, more than the mass of all the stars in the Milky Way. By the way, galaxy clusters are some of the biggest objects in the universe, containing thousands of individual galaxies, dark matter, and hot gas. What caused this eruption? It was due to gravitational energy release as enormous amounts of matter fell toward a black hole. Most of the matter was swallowed, but some of it was violently ejected before being captured by the black hole. However, there are several things still puzzling scientists about the massive eruption. For example, they don't know where that large amount of energy came from. The astronomers estimated how much energy was needed to create the cavities by calculating the density, temperature, and pressure of the hot gas. By making a standard assumption that 10% of the gravitational energy goes into launching the jets, they estimated how much material the black hole swallowed. Besides generating the cavities, some of the energy from this eruption should keep the hot gas around the black hole from cooling, and some of it may also generate large-scale magnetic fields in the galaxy cluster. Chandra observations have discovered other cavities in galaxy clusters, but this one is easily the largest and the most powerful. For example, the energy content here exceeds that of the Perseus cavities by 250 times and dwarfs the holes in M87 by a factor of 10,000. Sometimes a powerful cosmic explosion occurs when two objects in space collide, and that is the case in the next powerful collision that we bring to you. When comet Shoemaker-Levy 9 met its end, it was in a collision with planet Jupiter so powerful that it left scars on the jumbo planet. It was the first collision of two solar system bodies ever to be observed. In fact, the explosion, which took place in 1994, brought the dangers of asteroid and comet collisions with Earth to the public fore. In the late 1990s, Hollywood released two blockbuster films, Armageddon and Deep Impact, whose plots were based on the idea of large objects endangering the planet. The event also galvanized the US Congress to authorize NASA to seek more near-Earth objects, or NEOs, to better monitor those that come cruising close to our planet. NEO research continues to this day at NASA, but thankfully the agency has not found evidence of the Earth being in danger of the kind of explosion that rocked Jupiter. Shoemaker-Levy 9 was spotted in 1993 by three veteran comet researchers, Eugene and Carolyn Shoemaker and David Levy. The group had collaborated several times before and discovered several other comets before this one, which is why this comet was called Shoemaker-Levy 9. From their calculations, the astronomers reckoned that the comet would strike Jupiter about a year later, even though the comet had been circling the planet for decades after being captured by its gravitational force. There was a spacecraft en route to Jupiter at the time, Galileo, which would orbit the planet, and it would have been spectacular to use the satellite to get a close-up. However, Galileo did not arrive in time for the explosion. Scientists had to use observatories around the world. The Hubble was also conscripted to document the event. The actual collisions ended up being a multi-day extravaganza. From July 16 to 22, 1994, 21 different parts of the comet smashed into Jupiter's atmosphere, leaving blotches behind. Unfortunately, all the collisions occurred on the side of Jupiter facing away from us. However, they generally occurred fairly close to the morning terminator, or the location on Jupiter that was shortly moving within sight of Earth. This allowed our telescopes to examine some of the impact sites just minutes after the collision. The outcome of the explosion was that Jupiter's bright surface was dotted with smudges, marking the spots where the comet smashed through the atmosphere. Astronomers using Hubble were surprised to see sulfur-bearing compounds such as hydrogen sulfide, as well as ammonia as a result of the collision. However, about a month after the collision, the sites were noticeably faded, and Hubble scientists concluded that Jupiter's atmosphere would not have any permanent changes from the impacts. But that does not mean Jupiter escaped unscathed. When Galileo eventually arrived at Jupiter and took images, scientists discovered ripples in the planet's main ring. The entire ring was also tilted about 1.24 miles thanks to the explosion. And almost 2 decades later, New Horizons, while on its way to Pluto, detected disturbances in the rings. And now to the most enormous cosmic explosion since the Big Bang. This massive release of energy emanated from a supermassive black hole some 390 million light-years from Earth. This is why we were safe on the Earth. However, the Ophiuchus galaxy cluster was not so secure because the explosion left a giant dent on it. At the heart of the Ophiuchus cluster, there is a large galaxy that contains a supermassive black hole with a mass equivalent to 10 million suns. Although black holes are known as sinkholes that consume anything that drifts too close, they also expel prodigious amounts of material and energy. One of the scientists that reported on the explosion, Melanie Johnston-Hollett, tried to put it in human terms, saying if this explosion continued to occur over the 240 million years of the outburst, it would be like setting off 20 billion megaton TNT explosions every thousandth of a second for the entire 240 million years. So that is basically incomprehensibly big. Scientists had long felt there was something strange about the Ophiuchus galaxy cluster, which is a giant aggregation containing thousands of individual galaxies intermingled with hot gas or plasma and dark matter. In fact, US and European X-ray telescopes had spied a curious curved edge to it. NASA's Chandra X-ray Observatory spotted the first hints of the giant explosion in 2016, which showed an unusual concave edge in the Ophiuchus galaxy cluster. However, at the time, the possibility of this being caused by an explosion was discounted due to the vast amount of energy required to create such a large cavity. The latest observations combine data from Chandra and ESA's XMM Newton Space Observatory and radio data from the Murchison Wide Field Array, or MWA, in Australia and the Giant Metrowave Radio Telescope, or GMRT, in India to provide compelling new evidence for the gigantic explosion. The observations confirm the presence of the curved edge and also reveal a colossal patch of radio emissions tightly bordering the curve, which would correspond to the expected bubble. However, the speculation was that this might be the wall of a cavity that had been sculpted in its plasma by emissions from an immense black hole in one of the core galaxies. Black holes are famous for gorging on infalling matter, that is, any gas or even stars that happen to get too close, but they can also expel prodigious amounts of material and energy in the form of radio jets that then slam through the local environment. Scientists at first doubted the black hole explanation, however, because the cavity was so big. It implied the black hole emission would have to be unimaginably large. The combined data show that the curved edge is indeed part of a cavity wall because it borders an area rich in radio emission. That emission likely resulted when the black hole's outburst accelerated electrons to nearly the speed of light. The amount of energy required to create the cavity in Ophiuchus far exceeds the previous record holder, which we told you about earlier. According to the researchers, it is hundreds of thousands of times greater than explosions typically seen in galaxy clusters. To give it another dimension, the cavity is about 1.5 million light-years across, so the hole that was punched in the surrounding space in the hot X-ray plasma would take light itself 1.5 million years to traverse, so it is absolutely enormous, the amount of energy that we're talking about here. The first set of scientists that suspected there was a massive explosion in the Ophiuchus galaxy cluster calculated that it would take about 5 times 10 raised to the power of 54 joules of energy to create such a cavity. For perspective, all the energy consumed by humans globally per year is about 6 times 10 raised to the power of 20 joules. In some ways, this blast is similar to how the eruption of Mount St. Helens volcano in 1980 ripped off the top of the mountain. However, imagine that you could fit 15 Milky Way galaxies in the crater caused by the eruption. Now, while the explosion in the cluster MS0735 6+7421 is still going on, the mighty Ophiuchus fireworks appear to be over. As the scientists said, the radio data show no evidence for ongoing jet activity. Also, from the data, scientists discovered something quite odd with the Ophiuchus explosion. The data revealed just one region of radio emission, but black hole jets usually go off in 2 different directions. However, it is possible that the jet feeding gas on the other side, that is, the one opposite the detected cavity, was less abundant, and the radio emission there dissipated more quickly as a result. Remember we said NASA had not detected any evidence that the Earth is in danger of an explosion caused by a comet. Well, that has not always been the case, and the older inhabitants of the Earth were not so lucky. The explosion is known as the KT extinction, and it changed the Earth forever. KT extinction, which stands for Cretaceous Tertiary Extinction, is a global extinction event that led to the perishing of about 70% of the species living on the Earth within a very short time. This happened some 65 million years ago, and the mass extinction is termed KT extinction. This was at the end of the Cretaceous period and the beginning of the Tertiary period. When ranking major mass extinctions, KT extinction comes third in severity among the top 5. KT extinction was caused by an asteroid 15 kilometers in diameter hitting the Earth, forming a crater at the tip of the Yucatan Peninsula in Mexico. This crater, known as Chicxulub crater, is about 110 miles wide. The force of the cosmic impact was equivalent to about 10,000 gigatons of TNT exploding, or about 1,000 times of the world's nuclear war chest. The crater's impact penetrated the Earth's crust, releasing a large amount of dust and debris into the atmosphere. It caused tsunamis, fires, windstorms, acid rains, and volcanic activities. The dust also blocked the sunlight coming to the Earth and lowered the planet's temperature. 90% of marine species, 50% of marine genera, 85% of land species, and 56% of genera went into extinction as a result of KT extinction. In fact, this catastrophic event ushered in the mammalian age. The most popular casualties of the explosion are the dinosaurs. It proved to be the straw that broke the camel's back after their population had been steadily declining. The survivors of the KT extinction include birds, dinosaurs, and crocodilians, and they evolved into modern birds and crocodiles. Among the marine flora and fauna, only 13% of the plankton survived. Sometimes the remains of the dead organisms are preserved as fossils. Scientists managed to piece the events of the KT extinction together by comparing the fossils found at the end of the Cretaceous period to that at the beginning of the Tertiary period. The KT extinction was not the only powerful explosion to happen close to home. More than 2 centuries ago, in 1815 precisely, Mount Tambora in Indonesia exploded. The outcome changed the global climate for years. It also led to mass migration and revolutions, changing the social and political fabric of the time and region significantly. More than 70,000 people perished in the immediate aftermath of the explosion, and hundreds of thousands more died due to diseases and famine traced to the ugly event. So how big was the Tambora explosion or eruption? The blast generated 175 cubic kilometers of volcanic debris. How much is that? Well, it's enough to cover all of the playing surfaces of Fenway Park in Boston by 81,544 miles or 131,322 kilometers high ash. Or you could bury the state of Rhode Island in 183 feet or 55 meters of ash, or Singapore in 805 feet or 245 meters of ash. The devastating speed with which Tambora exploded continues to amaze scientists today. Research showed that the whole eruption could have lasted less than 3 days, meaning that at its peak, Tambora was releasing between 300 and 500 million kilograms of materials per second. By comparison, that's about 178 times the amount of mass per second that Niagara Falls handles. Scientists have worked out the estimated amount of energy released during the Tambora explosion. They arrived at the mind-blowing value of 1.4 times 10 raised to the power of 20 joules of energy, or the equivalent of 33 billion tons of TNT. In comparison, the 2004 Indonesian earthquake that generated the Boxing Day tsunami released about 110 petajoules of energy. That means Tambora was about 1,200 times more powerful than the 9.3 magnitude earthquake. So what were the consequences of the Tambora explosion? Before the eruption, Tambora was a volcano about 4,300 meters or 14,100 feet tall, which was about the same size as Mount Rainier. Mount Rainier is also prone to eruption, so it is an apt comparison. However, the explosion produced a caldera, or a large depression caused by the volcano falling in on itself after emptying its innards during the eruption. The Tambora caldera is 1.2 kilometers deep, meaning that the volcano lost at least a few kilometers of elevation in a matter of a day. However, can an explosion of the magnitude of Tambora happen again? Well, according to evidence from the geological record, the chances of another eruption the size of Tambora occurring somewhere on Earth is about 10% in the next 50 years. Scientists expect another such explosion to come from a volcano in the same Indonesia. It is basically a matter of time. While we have developed sophisticated warning systems, the question is, are we prepared for another Tambora explosion? Let's hear what you think are the most powerful explosions in the universe in the comments section below.